In this demo, we're going to retrieve the different configurations, create a pipeline run for each configuration, monitor the pipeline runs, get the best configuration, plus look into hyperparameter optimization. All right, the first step in this demo is to create a Katib configuration. So we execute the cell that you see there on the screen. Then next, we want to actually run the AutoML experiment. So we find that particular cell and then we execute it. And in the output, you're going to see two hyperlinks. The first one is going to be the experiment details hyperlink. When we click on it, it allows us to basically view the Kubeflow pipelines experiment. You can see that it has automatically navigated us to the experiments view in the central dashboard. If we click on the run details link in the output, it'll take us to the runtime execution graph for this particular pipeline. And you can recall that in real time, the pipeline execution graph is going to be updating whether it's in process or it has completed. Once it's completed, we'll be able to move on to the next step where we are going to get all of the different configurations that are available. In order to retrieve the different configurations, we're going to want to look at the runtime execution graph, and specifically we want to look at the get meta learning configuration step. So in this step, Kale is asking AutoSKLearn to provide AutoML configurations. And a configuration is an AutoSKLearn suggestion that's composed of a model architecture and a combination of model parameters that AutoSKLearn thinks will perform well on the provided dataset. So in this example, Kale is asking AutoSKLearn to produce 4 different configurations, and you can see where this is being specified back in the notebook in this particular cell. Next, let's view the configurations. So if we click on the step and then go to the ML metadata tab, we'll see the configurations that AutoSKLearn has produced. Now let's view the second configuration. Click on it. Let's view the model and the initialization parameters. And now we're ready to create a Kubeflow pipelines run for each configuration. Now we want to recall that AutoSKLearn configurations are just an empty description of a model and its parameters. We need to actually instantiate these models and train them on our data set. So Kale is going to start a pipeline run for each configuration that will start 4 pipeline runs. So by default, these pipelines will run and execute in parallel. You can see that specification here, and this can be a massive task for your cluster. So here we're configured Kale so that it starts just 2 runs simultaneously at any given time. So then Kale is going to produce these pipeline runs during the run meta learning configuration step. And then we'll notice that the pipeline icon that the steps has means that it produces 1 or more pipeline runs. Next, let's go to the run meta learning configuration step. If we click on the step and go to the ML metadata tab, we'll find that those 4 runs that Kale produced during this step. Next, let's view a configuration pipeline run. So we can just click on one of them and view the pipeline run. And as we can see, the pipeline consists of a run sklearn transformer step that transforms the data set on a train sklearn estimator step that trains the model, and the infer sklearn predictor step that predicts over the test dataset. During the pipeline runs, Kale is logging MLMD artifacts in a persistent way. These artifacts are backed by ROC snapshots, so they are versioned and persistent regardless of the pipeline's lifecycle. This way you can have complete visibility of the inputs and outputs of the pipeline steps, and most importantly, you can always be aware of the dataset, the model, and the parameters you used in the training process. Next, we can view the artifact of this particular snapshot. And if we click on the Run sklearn Transformer step and you go to the ML Metadata tab, you can see the artifact of the ROC snapshot that contains the input dataset, and a Kale transformer, the object that is transforming the data. Next, let's view the artifact of the trained model. So if we go to the ML Metadata tab and the next step, which is called Train sklearn Estimator, we can see that the artifact of the trained model. Finally, if we go to the run output, we can see the pipeline metrics. The metric shows just how well this particular AutoSKLearn configuration performed on the dataset. Now let's go back to the runtime execution graph and go through the next step, which is the monitor KFP run step, which waits for all the pipelines to complete, and that's going to be 4 pipeline runs that have different configurations. When the runs succeed, Kale's going to get the one with the best performance. Kale knows this based on the optimization metric that we've provided in the notebook. This happens in the get best configuration step. Now that Kale has found the best configuration with the help of AutoSKLearn, let's see if we can't actually do just a little bit better by running a hyperparameter tuning experiment using Katib. So the first thing that we want to do is go and view the trials. And you'll notice here that our trial count is 2. Then what we're going to want to do is come back to the runtime execution graph, and let's look for the run Katib experiment pipeline step. When we click on it, we can actually then go to the ML metadata tab. And here we can find the corresponding Katib experiment. We can then click on the link and go to the Katib UI to view this particular experiment, view the trials associated with this particular experiment, and then we want to view the pipeline run with the best Katib trial. So we'll click on that pipeline icon. Now we want to view the run parameters for this particular pipeline, and we can do that by clicking on the config tab. Here we can see the runtime parameters. So let's recap what we saw in this demo. We showed how to retrieve the different configurations, how to create a pipeline run for each configuration, monitor the pipeline runs, getting the best configuration, and then conducting some hyperparameter optimization. Up next,